How are we looking, Jim? Are we kind of settling out in numbers, or are we still growing?
Yep, we're good to go. I've started recording whenever you're ready, sir.
All right. Well, again, good morning, everybody. This is Rob Macedo, KD1CY, the ARES, or Amateur Radio Emergency Services Skywarn Coordinator for the National Weather Service, Boston-Norton. I'm a volunteer with the Weather Office for the last, geez, I think it's almost 15 years, maybe a little under that, 13 or 14 years now. A few of us in the amateur radio community have been allowed to teach the Skywarn classes. Of course, it used to be at live venues until last year when COVID had struck. We've adopted to a virtual class format. And today we'll walk everybody through Skywarn spotter training. This presentation is open to all. And then after the class, if you're interested in becoming a spotter, there's a 20-question online quiz that you can take, and then you pass it, you will get a spotter ID number and information from the Weather Service on how to report in, which is also included in this presentation. One thing I'll mention from Bryce Williams, who's the forecaster, who is the Skywarn program leader for the office, is it is a very manual process right now, so it may take a while before you hear something, but you definitely will hear something from him. In a future basis, on the amateur radio community side, we may try to work with the Weather Office, see if we can help automate that process a bit more. We're still figuring out ways to do that, but we're going to see about trying to do that. I don't know if it'll affect this year's virtual classes, but we're definitely looking to help with that so that it's a more automated process in terms of getting your spotter ID and credit for the class. So, in any event, it's great to be with everybody today. I know it's a beautiful spring day today, so we'll try to get through everything within the 2 hours as quickly as possible here. So I'll start taking everybody through the training, and this is the GO-16 satellite imagery here. And you can see that during the eclipse, you can see how the satellite imagery shows that shadow going across the globe as the eclipse went through the area. This was just a few months after GO-16 satellites were enabled. They allow for 1-minute satellite updates. And you'll see a couple of things here. You'll see here in this area of the Caribbean, a tropical system that would go on to be Hurricane Harvey. You can see a hurricane out here in the Eastern Pacific. Those are a couple of examples of what the satellites can pick up in terms of tropical systems. You can see a front going through here, maybe some strong to severe thunderstorm activity up in the Great Lakes. But the GO-16 satellite imagery, again, it's 1-minute updates, which is even faster than what a full Doppler radar scan can do. It's I would say now, I guess I'd call it a relatively new tool in the toolbox because it's now been around for about 4 years that helps with severe weather, winter storms, etc., and helping to provide valuable data to the forecasters during forecasting. So again, that's the eclipse and the GO-16 satellite imagery here. So what is the National Weather Service? Well, it's kind of weather behind the scenes. So the Weather Service and the various national centers help provide all the weather modeling and that information that they use at the National Weather Service for their forecasts, but it's also used by a lot of the media. The models themselves come from the U.S. government and European government, et cetera. That information, those weather models that are built, are then used as the basis for forecasts from various other entities that may provide their own interpretations on those models. So, and then of course the spotter reporting and all that comes from the Weather Service and then is put out over radio, TV, internet, newspapers, cell phones, etc. So there's 122 local Weather Service forecast offices issuing local forecasts and warnings. And then the National Centers for Environmental Prediction. Again, that's what does all the modeling. With the Climate Prediction Center, is one of the centers that provides climate and seasonal outlooks, aviation and marine forecasts from the Weather Prediction Center, storm and tornado prediction from the Storm Prediction Center, hurricane tracks and watches and warnings from the National Hurricane Center. There's river forecasts from the various regional river forecast centers, all the different kinds of observations across the radar network, weather balloons, and volunteer daily data collectors of weather conditions, and then Skywarn and volunteer storm spotters are all part of observations that help with forecasts. So what is the National Weather Service? It's a federal government agency. It's sponsored by the U.S. Department of Commerce. It's part of NOAA, the National Oceanic Atmospheric Administration. And as always, we are asked to lighten up the mood in the class. So some jokes that they always provide, the forecasters. NOAA can also stand for a few other things. It can stand for the National Organization for the Advancement of Acronyms. It can also stand for no organization at all. So some humor that you'll see sprinkled throughout the presentation. The directive is protection of life and property, timely weather and river forecasts, and there's nationwide coverage with 122 local forecast offices and 11 national prediction centers. We mentioned some of those, like the National Hurricane Center, the Storm Prediction Center, and so forth. You can see on the top map here, some offices cover parts of several states. Some only cover part of a single state, especially in larger states such as Texas. Here at our forecast office, we cover all of Massachusetts except for Berkshire County, all of Rhode Island, and Hartford, Talon, and Windham counties of northern Connecticut. And this is our coverage area, and it's all based on how well the Doppler radar sees into given areas. In Connecticut, they have 3 different Weather Service offices covering them: the Albany office covering into Litchfield County, Connecticut, the New York City or Brookhaven, New York office on Long Island covering southern Connecticut, and our office covering the 3 counties in northern Connecticut. Southern New Hampshire was a part of our office, but was moved into the Gray Main coverage area on the request of New Hampshire Emergency Management, who wanted to just deal with one Weather Service office, because the radar actually sees a bit better into southern New Hampshire from the Norton office, but the Emergency Management wanted to just deal with one office, so it was moved to the Gray Main office. I believe that was around late 2014. So a typical Weather Service office has 26 employees, meteorologists, technicians, and others, staffed 24 hours a day, 7 days a week, 365 days a year, including weekends and holidays. Duties are all managing all the observations and spotter reports that come in, all of the forecasts out to 7 days, and all watches and warnings. And of course, with COVID, they're still manning that office 24/7, 365 days a year, but with a reduced amount of folks in the office and other folks assisting remote out of office, which has been the trend at many workplaces because of COVID. So why are you here, especially on a beautiful spring day and on a Saturday? Well, we need eyes on the ground because 1/3 of warning decisions are based on reports. So an example here is, this is June 23rd, 2015. And you can see here in this photo that we have, in this video, that we have what definitely looks like rotation and a funnel cloud. And this actually was a brief tornado that touched down just north of Mount Wachusett, Massachusetts. We had some reports of rotation, no real reports of damage or anything like this video is showing. But as the video surfaced and some damage information came in, the next morning this video was seen and a survey team was deployed and confirmed an EF0 tornado just north of Mount Wachusett. This same day also had an EF0 tornado touchdown in the town of Wrentham, Mass. So there were actually 2 tornadoes on this day, June 23rd, 2015, about 6 years ago. So this is that's what happened on that date, and that's the importance and the difference of getting spotter information in near real time versus getting it sometime later on in time, and how it can affect the warning process. So what is Skywarn? Skywarn is all of you, the civilian volunteers trained by the Weather Service to report specific weather conditions to the Weather Service: wind gusts, hail size, rainfall, cloud formations. Skywarn spotters can be anybody, average citizens. You don't have to be an amateur radio operator to be a spotter, but amateur radio and through the ARRL, the American Radio Relay League, and the Weather Service have had a memorandum of understanding for many years. So there's a strong partnership there, but you don't have to be an amateur operator to be a part of the program. And the Common Bond is interested in weather and helping public safety. So I'll give an example here of a bad Skywarn spotter here in this video, and we'll play it through. And Jim, I'll just have you give some feedback on the audio quality when we're done with the video.
Like driving through a tornado right now.
So that's the video. Jim, did that audio go through okay?
Yeah, the audio is a little quiet, but I think we heard it, and he's definitely a little bit more attentive, I think, to the storm than to the road in front of him, I think we'll say.
Well, right, there's that. And also, Jim, did you see a tornado in this video?
You know, I'm not exactly sure that I did. I saw a lot of trees bending, a lot of wind-whipped rain, but I did not actually see the tornado.
Yes, no, and I didn't see a tornado either, and that's why we say this is a bad example of a Skywarn spotter. There's definitely torrential rain, and that may result in some flooding. We definitely see some strong winds with the way that tree is bending over. If it gets stronger or those winds last long enough, it could bring that tree down, which is something we'd want to hear about. But there's no real tornado there, and this is why we say it's a bad example of a Skywarn spotter. Because it's just not reporting exactly what you're seeing or reporting based on a criteria that we'll talk about, but we won't get to that till the second portion of the class. So that's why we say this is a bad example of a Skywarn spotter. So reported tornadoes 1950 to 2020. You'll see the numbers here, and you see the numbers are Worcester County is 43. That's a big county. If you kind of add these guys up here, it's a little bit more, but about the same as what Worcester County would have. And you see the numbers are higher here and then start to tail off as you get into southeast New England. Well, why is that? So what happens typically is to get rotation for tornadoes, you generally have a south and southeast wind at the surface with a west and northwest wind aloft. That's what gets the turning in the atmosphere going. That starts the tornadic process. Well, when that happens in our region, when we get those south and southeast winds, what happens? Typically, especially in the spring, especially this time, April, May, into a good chunk of June, our water temperatures are much cooler. And what that does is it reduces the level of instability. So you could get that rotation and you might have good winds aloft, but if you don't have the instability, you don't have all the thunderstorm ingredients in line for tornadic activity. So it reduces the numbers here as we get into southeast New England. But as you can see, it's not zero. Many of these areas have at least had one tornado. Even Block Island had a recorded tornado back in August of 2012. So that's why these numbers are reduced, but they are not zero. It has to do with that cooling in the first part of the spring. So that's what we see here during across the region in southern New England during our springtime. As we get towards summer, those conditions, the ocean is warmer, and then that kind of mitigating influence of cooler water temperatures ebb. Also, sometimes when we have cold pools in the atmosphere aloft, that can also mitigate the cooling of the waters, because you get that temperature difference that the water temperatures don't really mitigate that. So those are a couple of reasons why the water helps reduce the number, but it doesn't make it zero if you live in southeast New England. And then the numbers are higher as you get out into interior western New England. Last year we had 2 tornadoes, which is basically our average. If you look at 2018 and 2019, 2018, we were way above average. We had 11 tornadoes. That was basically a little over 5 times the average. They were really all EF0 and EF1 tornadoes, but there were quite a few of them. And then in 2019, we had 5 tornadoes, including 3 on Cape Cod. And then we had 1 in Connecticut and 1 in Rhode Island in 2019. This past year, there were 2 tornadoes. One was in Tallinn in Blandford, Massachusetts area back in August, a couple of days before Tropical Storm Isaias. The other tornado was in Millis, Massachusetts, and that was part of the derecho that went through our area. You can see quite a few wind reports and then hail reports, 1 inch plus, a number of those. If you counted reports under 1 inch hail, these numbers would be quite a bit higher. My understanding of these statistics is that it covers the first report that confirms a severe thunderstorm warning, or a report that comes in of this criteria where no warning was issued. So the numbers of actual reports can be, across an event can be a bit, quite a bit higher than this, but it's really focused on the first report that verifies a warning or a report where no warning is issued. So that's the background to these numbers, and some information as well on tornadoes in the past couple of years. Preparedness websites, there's weather.gov/Boston, which is the local NWS office website. The Storm Prediction Center, SPC, they're the ones that issue the tornado and severe thunderstorm watches that cover usually large areas, multiple states. And the watch means conditions are possible. Doesn't mean watch out, it's coming right away. It means conditions in the area are favorable for tornadoes or severe thunderstorms, depending on the watch, and to get people to keep an eye to the sky and be prepared for the possibility of severe weather. When a severe thunderstorm or tornado warning is issued, that's usually over a smaller area, usually parts of counties. Sometimes they can be multiple counties and bigger, particularly when you're dealing with more of a widespread line of storms. But those warnings, severe thunderstorm and tornado warnings, means those conditions are imminent or are occurring, and those are issued by the local NWS office, in this case our Boston-Norton office. And then there's preparedness websites, ready.gov, Mass Emergency Management, Rhode Island Emergency Management, and Connecticut Emergency Management, and those links are provided below. On a preparedness perspective, social media, NWS Boston has a large presence on Facebook and Twitter, and they put out a lot of preparedness infographics during storms, as you can see from some of the images here below. From preparedness, our amateur radio station at the Weather Service Boston-Norton, which we have not used much due to COVID. It was used once last year during a storm that happened to coincide, a winter storm that actually coincided with Skywarn Recognition Day. Our warning coordination meteorologist, Glenn Field, is an amateur radio operator, and he staffed the station for a couple of hours to thank spotters for the Skywarn Recognition Day event, but also to take reports during that winter storm. We still have the station there, and when the pandemic finally loosens its grip on our area, I'm sure we will be back in some form again with direct operations at the Weather Service office. We have been doing our operations remotely via our home and other location amateur radio stations. But as part of that, part of amateur radio, for those that aren't familiar with it, is it's a form of social media in a lot of respects, in addition to kind of being a communication means when things fail. And they kind of augment communications when they are up. So we do have modern forms of social media. We have our WX1BOX Facebook and Twitter feeds. That are on social media. Our amateur radio call sign, and you see it right here, is WX1BOX. And it's the same on Twitter. You can see at WX1BOX. We interact with some of our amateur radio spotters. You may not be near a radio when they have something to report. And also our non-amateur radio Skywarn spotters. You'll see often that NWS Boston will say copy both WX1BOX and the office on your social media reports, because we can help manage the information and the data flow coming in. We also will post the infographics from the Weather Service on our social media feeds, and we have an email system that does coordination messages, and we post that information on social media and our website, wx1box.org. We also will post post-storm reports and photos with credit during and after the event for situational awareness. So just some additional means of preparedness and social media, and also getting those reports out there that folks are doing, because it makes a difference, and they are used by the media. The Weather Service has their public information statement and local storm report products. I know sometimes people say, well, not all the reports are in there. Sometimes that's very difficult because there's so many, but I can tell you that if they're not in those reports, they can get used in a lot of other ways. We put it out on social media. Sometimes the media will pick up and use those photos and reports. We send out email reports of information that's beyond that has information that can be beyond the storm report. So there's even storm data, a collection that's done on a monthly basis after weather events. This data gets used in one form or another. So and it can be it's very important to the process. So it's used and can be distributed in a lot of different ways. There's still preparedness with NOAA Weather Radio. It's still one of the best ways to get up-to-minute watch and warning information that comes directly from the Weather Service. And you can have the weather radio alerts that allow you to get alerts. You can have it really specific to your very localized area, or you can have it set up so that you can get some information and warning alarms to go off, from neighboring areas until it gets into your local area. It's programmable. You see the different transmitters here across our coverage area, and they all provide pretty strong coverage. This one right here is in Blue Hill. There's also one that's a specific marine focused NOAA Weather Radio transmitter that gives all of the marine updates, so that these other transmitters are just giving information over land, which has been good for the programming cycle to gather information. A lot of applications are available for iOS and Android in particular. I guess to an extent BlackBerry is still as well. Radar applications, there's even an application from NOAA Weather Radio. And in particular, there's the wireless emergency alert capability, which is used for tornado warnings and flash flood warnings. It can now be used based on categories for certain severe thunderstorm warnings. Not all severe thunderstorm warnings are created equal, but when we get to certain thresholds that could be considerable damage or very large hail, there will now be a capability to put out a wireless emergency alert for those kind of higher end severe thunderstorm warnings, which I think will be very important, because there are times where you can get a severe thunderstorm that maybe it's not producing a tornado, but if it's producing 90 to 100 mile per hour wind gusts, you're going to get the same kind of damage. So this is where that capability is going to be very, very useful to warning the public for those higher end severe thunderstorms. And that is a feature that is now enabled. This is an example from Concord, Mass. Of crews cleaning up after a tornado that hit the town of Concord. And this was a little after 3 a.m. We've had a couple of recent cases, once here in August 22nd, 2016, and once in July of 2018, where we had tornadoes kind of in the window between midnight to 5 a.m., or for lack of better terms, nocturnal tornadoes. They are rare in southern New England, but they do happen. We had the two incidents in 2016 and 2018. Previously, the last nocturnal tornado in New England was in 1970. So gives you an idea of we can get them, but they're on a fairly infrequent basis. And this is where the wireless emergency alert can be key, and this is what this video describes.
Beeping, which was different from any kind of text alerts or phone call, or it was clearly something wrong. And you may not know, those cell phones, those equipped to have those tornado warning emergency alerts. Now, many residents out here we talked to say they didn't know they had it on this phone, but now they say they're sure glad they did.
So, an example again of the wireless emergency alert, especially important during an overnight situation where you may be asleep. So just want to provide that example there.
And Rob,
so ingredients.
Before we continue, the audio on that last clip was pretty low. If you could just kind of summarize what was being said. We are getting a few reports. People weren't able to hear that.
Okay, yeah. See, this I was a little concerned with these videos that the audio would be low. I do have it cranked up all the way on my end. So basically, the video was describing how people were alerted when the tornado warning was issued for the Concord tornado, that the wireless emergency alert alerted them. They were able to take cover immediately. There were no injuries or fatalities from that tornado, despite it happening in the middle of the night. So that's what that video kind of describes here. We have, I think, a couple more videos with audio, but probably most of them are it's more the visual aspect, and I'll just kind of play it through with the audio, but kind of recap it here going forward. So thanks for that feedback, Jim. So ingredients of a thunderstorm. So there's several ingredients that are critical for thunderstorm development. You need to have moisture. You need to have lift. Typically, it's a cold front, but it can also be a warm front in a system. That's kind of the triggering mechanism or what provides the lift. And then you need instability, which is generally cooling aloft in the atmosphere with warm air at the surface. If it's warm aloft, you won't get the severe weather. And if it's warm across the whole column, you won't get it either. So some days where we have these 100-degree temperatures, if we don't have any cooling coming in at the higher levels of the atmosphere, it's just going to be a really hot day. You're not going to get much thunderstorm development. But if you get any kind of cooling in that atmosphere, then it can be, you can get a lot of instability, and then you can, with these other ingredients, you can get that thunderstorm development. We'll also talk a little bit about strong winds and wind shear aloft. That is another key thunderstorm ingredient. So moisture forms the clouds and precipitation associated with thunderstorms. Primary sources are in particular the Atlantic and Pacific Ocean and the Gulf of Mexico, and to a more limited extent, the Great Lakes. That's what actually gives us the precipitation in these storms. And then instability, warm, moist air near the ground with cold air above. The greater the instability, the more favorable conditions are for thunderstorms. They're getting that temperature difference, in the upper levels of the atmosphere versus at the surface. That's what creates the high level of instability that can then bring us into one of the key ingredients for strong to severe thunderstorm development. Sources of lift. That's the forcing mechanism. You can have the instability and all these factors. You need something to kind of trigger it, a forcing mechanism or a source of lift to get the thunderstorm process in motion. So fronts, it's simply a boundary between two air masses, a warm and humid or warm and moist air mass in front of it with a colder, drier air behind it, or a scenario where you have cold, dry air and you have warm, moist air bumping up against it. Those are fronts that potentially can be that source of lift to get the thunderstorm process going. So you have sources of lift. The warm front is when the warm air replaces the colder air. There's these are less conducive to producing severe weather than cold fronts, particularly here in New England. But it's interesting because these warm fronts, as you get into the spring and summer, have the potential to produce tornadoes because there's a lot more turning in the atmosphere with these warm fronts. But generally speaking, they favor widespread continuous precipitation, not as much of a severe weather threat, but it can happen along these warm fronts. The cold front, it's a much steeper slope because the cold air can sink rapidly. It's a leading edge. It's like a snowplow, which is why bands of showers and thunderstorms along a line or on a leading edge of the cold front are generally can be in a line configuration with a shift in wind direction as the front passes and a change in pressure, with pressure falls prior to the front and pressure rises ahead of the front. And this is much more common to get severe weather with these cold fronts, with the cold air replacing the warmer air versus the warm air replacing the cold air, but it happens in both situations. And then we can have a dry line, not really a factor in southern New England, very rare. It typically lies across in the plain states where it separates the moist air from the Gulf of Mexico from the dry desert air in the southwest U.S. You hear the term dry line. That's what causes these conditions. They're rare, if as it says here, not a factor here in southern New England. Sea breeze fronts, however, are actually fairly common because of us being so close to the ocean. That sea breeze boundary can be that source of lift that gets us into conditions for severe weather. And you can, and the sea breeze is basically what it says, winds coming in off of the ocean, off of the sea. Sometimes you hear things about land breezes. That's the opposite, where it's coming in off of land and then out into the sea. The sea breeze front is definitely can be a factor in severe weather. Oftentimes we can see some activity on these sea breeze fronts before a cold front or something else comes through that causes more widespread severe weather over an area. This was an example from last year of some thunderstorms that fired off of a sea breeze. It produced a lot of heavy rain here in the Weymouth and into the Randolph area. This sea breeze front would go on and produce severe thunderstorms in the Waltham Weston area with downed trees and power lines, in addition to the heavy rains. So this was a case of a sea breeze front. Wasn't a super severe weather outbreak day, but the sea breeze front provided a local focus for some isolated strong to severe thunderstorms, producing some heavy rain and flooding here in this area, and some wind damage up towards the Waltham Weston area. Orographic lift is another source of lift, especially in the Berkshires and the Worcester Hills. You can get the moist air riding up one side of a hill or mountain with dry descending air on the other side. And what that can do is you can have the heaviest rain on the upslope side here, whereas here on the downslope side, you can kind of have a rain shadow. It can cause kind of localized storms with heavy rain on one side versus drying conditions on the other. So this is an example of this, and we definitely have that here between the Berkshires and the Worcester Hills. This photo here is an example of some of that lift from actual terrain. We have 3 thunderstorm stages. There's the cumulus stage here, and right, we can get cumulus clouds. We'll probably have some cumulus clouds today, but they don't necessarily form into thunderstorms unless you start getting that moisture, instability, and source of lift together. Then those cumulus clouds will build, and then you will get your thunderstorm activity, and you'll get to this mature stage here where you can see the well-defined storm tower. You can even see some cloud features pushing up above the tropopause here, an overshooting top, which we'll probably talk a little bit more about later, and mature storm stage here, and then the dissipating stage here where you see it start to really fall apart and become much less defined and more wispy in the cloud nature. That's the dissipating stage. So kind of 3 thunderstorm stages: the cumulus stage, mature stage, and dissipating stage. The life of a thunderstorm, it can vary depending on the amount of time and what type of storm it is. You can see here, we'll talk a lot more about the rain area, the downdraft area, this area here, which can produce potentially a gust front out on the leading edge of the storm. And we'll talk more on the different thunderstorm stages, but as the water vapor condenses, it releases heat. That's what fuels the storm. And eventually, when the rain cools the entire process and the process of kind of the vapor and the heat is released to the point where that energy is gone, that's what the rain will kind of cool the entire process, dissipate all the energy, and that's when the storm goes into a dissipating stage. We'll talk about the various types of thunderstorms. We have the single cell, also sometimes referred to as the pulse type of strong to severe thunderstorm. That's an occasional severe threat. Usually it's not severe, but occasionally it reaches severe thresholds. When we get to the multi-cell clusters and multi-cell lines, that's a greater severe threat. And then the supercell is a significant severe threat. And so we'll kind of walk through these types of storms now as we go through this part of the presentation. So we have the single cell thunderstorms. Again, they also may be referred to as pulse type of storms. They usually last about a half hour, and they're occasionally severe. More often than not, they're going to produce small hail and gusty winds and minor flooding, kind of below a severe or a flood or a flash flood warning threshold. But occasionally they will bump into reporting into an area where we'll get severe hail and stronger winds. We won't be talking about those criteria until the second part of the training, but it's again basically saying these are mostly going to be strong thunderstorms, a little bit more than just thunder and lightning and heavy rain. Could have some hail and wind with it as well, but kind of falling mostly below severe thresholds, kind of only occasionally becoming severe. This is an example of a single cell storm. Hopefully this person is using a dash cam while videoing and not driving and videoing at the same time. But you can see this is what it looks like on the radar on the right. This is the thunderstorm tower here, a single cell storm. Again, heavy rain, small hail, gusty winds, maybe kind of bumping into marginally large hail and more damaging winds. Those are the single cell thunderstorms. So that's the single cell. And then we have the multi-cell clusters. They can last 1 to several hours and they may become severe. A better threat for hail, a better threat for strong winds, a better threat for flooding. One of the key features that you'll see, as I mentioned, the gust front in a prior diagram, you also will get a shelf cloud that's along the leading edge of the storm. And under the shelf is strong to damaging straight line winds. Then you'll get your heavy rain, hail, maybe another period of strong winds before moving out of the multi-cell cluster. So we'll give some more examples here. These are some storms from 2013. They produced heavy rain, hail, and strong winds in the Fitchburg-Leominster area, also in the Connecticut River Valley and Pioneer Valley area. They also produced large hail up over a quarter size in diameter, and even some pockets of wind damage associated with this activity. And you can see here there's more than one storm here. There's a couple of storms kind of working in tandem and sharing the same updraft, which is helping to sustain those storms a bit longer than in a single cell instance. There's also squall lines or multi-cell lines of activity. They are lines of severe thunderstorms that can form along or ahead of a frontal boundary and can be linear in structure and more than 100 miles long. And they're preceded by a shelf cloud, which usually extends from horizon to horizon. So you can see that here from Wolfgang and Needham. This was a squall line of storms. And sometimes they can be what we call low-topped. Sometimes people think we have to have storms 50 or 60,000 feet to produce severe weather, and it just depends on the day. Some days, a 20 to 25,000 foot storm will be enough, and it depends on the atmosphere, the atmospheric heights, and some of the thunderstorm ingredients that we talk about that will determine how tall a storm has to be to produce severe weather. And this day here, this was May 21st, 2006. This was actually a low-top severe thunderstorm day. Under this shelf cloud is strong to damaging winds. And you can see here, you have this sometimes referred to as a gust front or an outflow boundary, kind of it kind of is out ahead of the rain and the hail. And again, under the shelf is the strong to damaging winds. Multi-cell lines can last hours or even days. They're often severe, and they're the most common type that produces severe weather in southern New England: hail, damaging winds, and flooding. If you look at what we had on October 7th of last year, which we called the derecho, which is Spanish for big wind, that's kind of the highest form of squall line you can get. That's basically what we had, was a prolonged squall line. It started in central New York. It lasted a good 6 or 7 hours and made its way from central New York all the way through southern New England and off the coast of southern New England. I even had damage right in New Bedford, just a couple of houses away from my house in New Bedford, and we had wind gusts measured at 61 miles an hour. So these are, so they can be that significant, and it's definitely one of our most common forms of severe weather in southern New England. This is an example from June 9th, 2011. It was actually one of the last times we had a moderate risk for severe weather in parts of our area. That did happen again in 2018. This was an example here, May 15th, 2020. And in this scenario here, we had quite a few damage reports across the line, especially though in northern Massachusetts. The Westford, Acton area had a microburst with measured winds over 90 miles per hour. Some of the damage looked like over 100 miles per hour, and there were widespread power outages in parts of Westford and Acton from this squall line as it swung through the area. It did weaken, as you can see, as it started to approach southeast New England, which is fairly typical for mid-May. So multi-cell lines definitely can produce hail of all sizes, damaging winds, and flooding because there's just that much more activity along the line. And you can see we get them. There's an example from June 9th, 2011 and May 15th, 2020. This actually on June 9th would have been one of our most prolific severe weather days, but 8 days prior was the Massachusetts tornado outbreak that included the EF3 tornado in the Springfield area out through Sturbridge and Southbridge. And hard to believe that we are going to be approaching the 10-year anniversary of the Springfield tornado. So that is hard to believe. I know we had operations at the Weather Service office, and I remember that day very clearly. We talk about the squall line. We're talking about that shelf cloud. Under the shelf, again, is the strong to damaging wind. Marks the leading edge of the updraft, downdraft region of a squall line, slopes down away from the precipitation. So as this shelf cloud is approaching you, you will likely feel winds pick up, and when those winds increase, they could be enough to cause wind damage. And then comes the rain and hail and potentially some winds associated with the actual thunderstorms. The shelf cloud is a multi-shaped cloud. It's attached to the storm base sloping away from the rain. You can actually detect it on the radar here as it's moving through Rhode Island. The winds will weaken as they get further away from the storm activity, but it's produced by the rain cool air, and you can see sometimes it will also spawn additional thunderstorm activity along it. You know, it's an outflow boundary sloping away from the rain. Straight line winds is the main threat. This was from South Kingstown, Rhode Island in July of 2015. This actually produced large hail and pockets of wind damage. There was even a tornado warning issued for the storm, but no tornado touchdown was confirmed. It was all straight line wind damage. Shelf clouds can look pretty ugly. If you see here in this video, you'll see that there's a shelf cloud. It's extending horizon to horizon at Race Point Beach. We'll get many reports. They're funnel clouds, they're wall clouds, they're tornadoes. But what you've got to remember is if you're on the leading edge of the storm, and it's extending from horizon to horizon, it's a shelf cloud, and it's something you got to be aware of because it could be strong to damaging winds under the shelf. Certainly, there's lightning with those thunderstorms, and it's time to get off the beach. But they can often resemble snow plows, big waves, spaceships, question, it could be that, it can be scary looking and whatever, but the key thing to remember is it's not a indication of tornadic development, but it is an indication of organized thunderstorms, and the potential for strong to damaging winds under that shelf cloud and in those thunderstorms is the threat to public safety. Then we have the supercell thunderstorms. These are some of our most powerful storms and the most likely to produce tornadoes. The additional ingredient here, and it does happen too with in particular for squall lines of storms, is having wind shear and turning with height. So directional shear, as mentioned here in this diagram, and you can see how the winds change with height in the atmosphere. This wind profile will get these horizontal rolls to develop, and you want the change in direction and enough wind speed or speed shear to be able to get these conditions for supercells and tornadic activity. The strong winds aloft increases organization and longevity of the storms, increases the threat for severe storms with a better chance of rotation and tornadic development. So if you have a scenario where you don't have strong winds, it's kind of straight up and down. That's what this diagram is showing here. When you get the strong wind shear, that's when you get the stronger updraft. It tilts the sheared environment. You can get the rain out ahead of it, and the hail, and then behind it in that updraft, downdraft interface area is where you could get the rotation and the actual strong to severe thunderstorm development that produces tornadoes. So a vertical wind profile. So for single cells and multi-cells, you can see the wind speeds are fairly weak, right? And that's a factor. So, or sometimes, we'll get these single cells and multi-cells, and we might have some pretty strong winds, but if we don't have the instability, the convection will be kind of in this category as well. But especially when we don't have the winds, they're kind of more unorganized and more what we call pulse-like and less organized in activity. When we get to multi-cells and squall lines, you can see here that you get the strong winds here, but it's kind of all in the same direction. And that's what will form multi-cells and squall lines. Then when we get the different direction in the atmosphere here and the even stronger winds, that's when we have the potential for supercells. Supercell thunderstorms can last hours and most likely to become severe. They are the least common in the Northeast, but we do get them, right? We had that on August 2nd of last year, which produced a tornado in Tolland, Massachusetts, and Sandusfield, and kind of lifted in the Blandford, Mass area. We can also have that and not necessarily get tornadoes, but get the large hail and damaging winds associated with it. It depends on the year. We may have one or two in a given year. On 1 year, we may get a dozen or a couple dozen, and this is across our whole coverage area. It just kind of depends on the year. If you look at June 1st, 2011, we probably had over a half a dozen just on that one day alone, and then kind of evolved into a squall line of activity. It just depends on the year, but it's definitely our least common of the thunderstorm types in our region. Large hail, damaging winds, and tornadoes are all threats. The updrafts can surpass 100 miles per hour. Most ideal conditions with winds are veering, turning clockwise with height. So when we get that clockwise turning in the atmosphere, that's why I say south-southeast at the surface, west-northwest as you go up in height, that's turning clockwise. That's when you'll get that potential for supercell activity. I talked a little bit about this in an earlier slide. You get your main storm tower here. This is your anvil and tropopause, which is a stable part of the atmosphere. And then above that anvil and tropopause is that overshooting top. And that's an indication where you can punch through that stable layer of the tropopause that you have very organized conditions for strong to severe thunderstorm development. This is a top-down view. We talk about hook echoes. Not all hook echoes produce tornadoes, but every tornado has a hook echo. This is kind of the hook type of signature that you can see. And we superimpose a radar image here. Notice this is the Springfield, Mass. EF3 tornado, June 1st, 2011. So this isn't from the plains or the Southeast United States or something. This is right in our own coverage area. This was June 1st. We were getting 2-inch hail reports here in the Fiskdale-Sturbridge area. And this area here, this is not precipitation, this is debris. And what we call a debris ball signature, that was where the tornado was as we were getting back into the Munson, Mass area. So this is an example right in our own area of a organized supercell with a large tornado on the ground doing damage. This tornado was on the ground for 38 miles. Supercell feature, this is when we can get a wall cloud, which is an abrupt lowering of the rain-free base. Many wall clouds will exhibit rapid upward motion and cyclonic rotation, but not always. This is an example of a wall cloud with rotation. This is an example of a wall cloud, it didn't rotate. And wall clouds are important to note and report, but not all wall clouds will necessarily turn into funnel clouds and tornadoes, but they are the first significant step in that process. Notice it's in the rain-free base as mentioned. Notice also that it only covers a portion. It's not horizon to horizon. It only covers a portion of the atmosphere. And notice it's sloping. There's your rain here. This is sloping toward the rain. So some differences from shelf clouds. You can see the video here. Supercell feature, we will get a rain-free base, a horizontal cloud base with no visible precipitation beneath it. That's the location of the thunderstorm updraft, and wall clouds will attach to that rain-free base. You can see that example here of it organizing. You can see here a defined wall cloud. Your rain is off to the right. It's pointed toward the rain. This is an area to look for possible funnel cloud and tornadic development. So we're spending a lot of time on wall clouds versus shelf clouds. So how important is this? It's really important because they both have different kinds of severe weather threats associated with them. The shelf cloud is an outflow feature that slopes away from the rain. It's associated with a squall line. It's at the leading edge of the storm, and it extends horizon to horizon. And under the shelf is the threat for strong to damaging winds. So in South Kingstown, Rhode Island, where you're seeing this feature and you're outside with tents and such, it can be dangerous because there could be strong enough winds that can, potentially knock over portable equipment and tents and maybe down trees and power lines as well. A wall cloud is an inflow feature that slopes towards the rain. It's associated with a supercell, and it's at the rear of the storm. And it's one of the first biggest steps towards possible funnel cloud and tornadic development. Doesn't always happen, but that's part of what the first kind of formative stage of that process. And you can see the cloud features are very different in nature. These often get confused. Many people will see what they see on the left video and think it's a wall of clouds approaching them, but you've been to training and you'll know that that's a shelf cloud, and under the shelf is strong to damaging winds. If you see a feature like this, oh, this is a wall cloud feature, I'm going to keep an eye to see if there's any tornadic development, funnel cloud and tornadic development with this wall cloud. And you don't have to be a radar expert, but you can kind of use radar to help you figure out where are you in the storm and what might you be seeing. So you can see here these discrete supercells on radar here, these 4 discrete supercells, and you can see the hook echoes associated with them. These all could be showing letter B, this wall cloud type feature. Whereas here you see this line of storms, you're likely, if you see what's in letter A, that's what you're likely seeing a squall line. This is a shelf cloud, and under the shelf is the strong to damaging winds. So that's the difference. And you can kind of look at radar, know where you are within the radar, and figure out what might you be seeing if you're unclear. And again, you don't have to take an extensive radar course to really look at that. You can just kind of look at where you are. You leverage your training here and figure out where are you within the storms. If I'm in certain positions ahead of these cells, I could potentially be seeing more what I would see in letter B. If I'm ahead of this line of storms, I'm most likely seeing what's in letter A. And you see here, letter A, the squall line, the shelf cloud, B, the wall cloud, and associated with any of these potential supercells. Both are a public safety risk. As I mentioned, these are, if you get 40, 50, 60 plus mile per hour wind gusts from this underneath the shelf cloud, this is impactful for all these people outside, tents, etc. There could be injuries and such, and that has happened. This is just as big of a public safety concern as is this feature here, which is the wall cloud, and this is in Lincoln, Rhode Island. This eventually went on to produce the EF0 tornado in Rentham, Mass. I mentioned funnel clouds quite a bit. It's a rotating column of air not in contact with the ground. It's kind of the next step beyond a wall cloud. As the funnel descends, the water vapor within it condenses into liquid droplets. That's what makes the funnel visible. Can be confused with Scud. This is in Stoughton, Mass. This looks like what we call Scud clouds, kind of cloud fragments or low clouds. But what you see here is that it is actually attached to a bigger cloud base. It's rotating. This actually was a weak EF0 tornado in the town of Stoughton, which likely would have never been confirmed if it wasn't for this video. The damage was very light, a few trees and wires down near this garage. The key thing was at this garage, some trailers were moved in different directions from this tornado, and this video evidence made it clear it was an EF0 tornado. So, it's not always easy and straightforward, but these are, the funnel cloud, that's what you see. It's a rotating column of air, not in contact with the ground. A tornado is a violently rotating column of air that is in contact with the ground. This was in Walcott, Connecticut, and you'll see here that the larger part of the vortex kind of stayed aloft, but you can see this looked a little bit multi-vortex. You can see some of the vortexes that were on the ground that was producing the damage. This was an EF0 tornado. You see the debris here. I think if more of this vortex was on the ground, this would have been a larger tornado, but it was these smaller vortices that were on the contact with the ground. You can see the debris that was flying in the air. So that is what a tornado is: violently rotating column of air in contact with the ground. Tornadoes can cause extensive damage. There's the EF scale, the Enhanced Fujita scale, which goes from EF0 to EF5. The different classes listed here, the different mile per hour and kilometer per hour ranges, and the descriptions of damage. The ranges start at 65 miles an hour. So tornado awareness, I know the audio may be a bit low here, but I think we'll play through the video, and we'll talk briefly about how sometimes with tornado awareness, you go from spotter to needing to look at things from a safety perspective.
Yep, there it is. Right here. Guys, we're in the middle.
So as you heard here, hopefully, and if not, I'll recap it. This is at a Home Depot in Howell, New Jersey. And from the video, you could see the tornado on the ground near the parking lot at the Home Depot. So definitely would want to report this to the Weather Service, but as you're reporting it, it's time to kind of get away from those windows, get away from where you're at and take cover, because if that changes direction or comes into closer to the store, flying debris could break those windows, could cause injuries, etc. So this is where we say tornado awareness, and you kind of suddenly are jumping in from a spotter role to kind of jumping into a safety perspective. So from an awareness perspective, if you had a smartphone and saw this storm system coming at you on radar, what would you do? Where would you go? What if this was the Indianapolis State Fair? Now, I know the grandstand, some questions of how structurally sound it was, but with this kind of feature here, that outflow boundary or that shelf cloud under the shelf could be the strong to damaging winds. Then we get to the heavy rain, hail, and maybe some winds with these thunderstorms. This is a definite public safety concern, and with the training, we want you to understand what would you do in this type of situation. From an awareness perspective, now you kind of know the basics and what to look for. Always observe the sky and your surroundings and be an active spotter. This looks like what we call scud clouds or cloud fragments. Right here, at least in this picture, this was cloud to ground lightning, and this was from July 4th, 2012, where they had to evacuate the Esplanade briefly due to thunderstorm activity. That was back on July 4th, 2012, and it's being aware of those scenarios. This is a video out of St. Louis, Missouri. There is no sound associated with this, so I'm just going to talk right through it. Seems like an average day. This is at the St. Louis airport. Seems like an average day here. Then you kind of start to see people. What's this person running here for? Person on the phone here, kind of walking around, but kind of heading towards the bathrooms. Don't know, did this store provide some bad food or something, or is there something else going on? You kind of see this person hovering near this area here, and then you see the TSA agents running to the bathroom, and then you see this. This was a tornado that ripped through the St. Louis terminal. This was 2011. There was wireless emergency alert on smartphones. Smartphones were probably a bit less out there than they are now. So the airport tower was well aware this was going to happen and affect the airport, but nobody told the terminal. This is a scenario that, again, being aware of your surroundings, being weather aware, and looking where to take cover. And the right place is these bathrooms, which are more reinforced by the piping, etc. And notice the hallway, all the debris that was blown through the entire hallway or terminal area where you would typically be walking through. So ask, where am I and where is the worst of the storm? We never want folks to put themselves in harm's way for a report. Where is the primary threat compared to where I am? What direction is the storm moving relative to me? We will discuss this through some of the radar and cloud formations in the next slides. So radar versus real life. This is what you're seeing for cloud features on the radar here. Where do you think you might be? Well, this looks like a shelf cloud along the leading edge of the storm. You can kind of see that in this area here. So we'll be at number 2, which is ahead of this multi-cell cluster of storms. They may be seeing the shelf cloud along the leading edge of the storm with the potential for strong to damaging winds. With a squall line, we can get a bow echo that kind of extends and bows out ahead of the line, and that's where the strongest part of the squall line will be. So if you look at this squall line here, there was activity in this part of northern Mass here that wasn't quite as strong as this area here in southern New Hampshire, where it was bowing out and surging forward. And sometimes at the head of the bow is where you can possibly get rotation and a brief tornado to form in that part of the squall line, where at the head of the bow where it is surging forward. And that's certainly where you're going to get the strong to damaging winds. So right in this area here is where the strongest winds are in that multi-cell cluster or squall line of storms. Notice the correlation of the actual shelf cloud to the radar imagery. So this is indicating some enhanced curvature here. And you can see that enhanced curvature in the clouds. So, you know, this is, again, you don't have to be a radar expert. You kind of see shapes on the radar. You can kind of look up at the sky and see, what am I looking at and where am I in relation to the storm, and get a better correlation of what cloud formation you might be seeing. Radar versus real life. If you're in this area here in the Narragansett, South Kingstown, Rhode Island area, and you see this coming at you from basically the northwest, notice these clouds look like they're very close, but these, again, just scud clouds and clouds ahead of that shelf cloud, and under the shelf is the strong and damaging winds. And sometimes we can get these cloud fragments, especially where we're near the ocean. We'll get these cloud fragments ahead of around that shelf cloud, and under the shelf is your strong to damaging winds, and you can see the rain and hail behind that shelf cloud where the strong to damaging winds are. We had measured winds with this storm activity between 50 and a little over 60 miles an hour. So spotter positioning, this is back to June 1st, 2011, and this storm is moving from left to right. You see the tornado is on the ground. It's doing damage. They don't know the extent of the damage. They're in a good spot, though, to view this, a safe spot. It's moving away from them. It's headed towards Munson and Fiskdale and Sturbridge. So they can report a tornado is on the ground. It's doing damage. Can't tell the damage from their vantage point, but they know it is on the ground and potentially doing damage. This position is a little bit more problematic. So they're able to see the tornado. They'll be able to see that it's on the ground because of some debris flying in the air. They can't see that it's all the way to the ground because the tree's in the way. You see the debris there. But the difference here is the storm ended up moving left to right, so they were okay. But if this storm, sometimes what they will do is right move or dive southeast. And if this dives southeast, this person is now in the direct path of this tornado. So if you're in this position here, you need to be ready to take cover immediately in case it turns towards you, because it could in that scenario. This person here, so they're definitely in the heavy rain. They may be getting even the large hail. Again, the storm is moving left to right, so in this case, they're not in a great vantage point to see the tornado, not to mention the trees that they have in the way. It would have to turn up toward them to actually be able to see it. In this case, they're not in a good position to see the tornado, but they may be in a place to report on the large hail and any flooding from heavy rains and that activity. Same thing here. This person again is in that same spot in the video there. It's the same slide there. It's again pointing to the same things I mentioned earlier. This person here is on the edge of the storm. Again, unless this moves straight up at them this way, it isn't. It's moving left to right. They're on the real fringe of this storm. And so they are not going to see much of the tornado or any of the large hail or heavy rains either, because they're kind of on the edge of the storm. And that's the real tricky things with severe thunderstorms and tornadoes. I mean, this again was a large tornado, it was an EF3 tornado, but you're talking about it affecting an area that was 38 miles long, about up to a half-mile wide path. It's relatively localized, but very significant where it occurred. And that's with severe thunderstorms and tornadoes, it helps to have a lot of spotters because this activity is so localized. And that's why there's such an emphasis on this part in the training, though we will be covering winter storms and other things as well. And there are scenarios where that is important as well. Spotter positioning. So this is from Michael Rossiker in Worcester. He actually lost his home in the June 1st tornado in Munson. He is in Worcester. This was around 8 p.m. on August 31st. We were actually training some amateur operators in the Weather Service office. Wasn't seeing a ton of activity till evening. Mostly was a flood threat. We were getting some 2 to 3 inch an hour measured rain totals here from these storms. Then as it was approaching the Worcester area, we got a bit of a wind signature. We called on our local amateur radio repeater, which is the Paxton repeater for any hams in the audience. And we got several reports, one from a security guard in Clark University reporting high winds blowing over the soccer goal posts, goal nets in the soccer field. And then a second amateur reported, I've got trees down in the street I'm on, and I watched a tree get picked up and thrown in the air, and a tornado warning was issued. And in that case, there was an actual tornado on the ground, and you can almost see it here. This is a night vision camera here. You can almost see it here with some of the debris. You could definitely see the strong winds. Kind of can see it here at the edge of the screen where it touched down and was on the ground just for a couple minutes and then lifted. We had damage reports from the city of Worcester in near real time. Within 4 hours, this was put down as an EF0 tornado in the city of Worcester. And this is how critical that spotter reporting process can be. And it was a clear result of why we had the tornado warning. Now I'm going to give another example from July 28th, 2014, which was a little bit different. We had a lot of reports of flooding and flash flooding from these storms across the area, Needham up through Malden, Winchester, whatnot. As it approaches the Revere area, though, and it was hard to see, it was rain wrapped, there was a EF2 tornado in the town of Revere. We did actually have some spotters that were at a location in Brookline that thought they were seeing rotation. They weren't sure if they were really seeing rotation, didn't report it in. We got reports of the damage in Revere in near real time. We also learned of damage reports all the way back in Needham, Mass, in a localized area, a good 5 or 6 hours after the fact. It was good that we got those reports, but there was a severe thunderstorm warning in effect, and then as it got into the Revere area, this literally, even though it was an EF2 tornado, it could be seen on the radar for about 4 minutes, and it was on the ground for about 4 minutes and dissipated, and it kind of went in between the radar scans to actually get something out proactively based on the radar signature. It kind of went from there was the storm and possible severe activity to possible activity that was on the ground in the matter of just the in between the scans of the radar. And this was right before we had the ability to do some partial radar scans within 2 minutes. This is where maybe if some of those spotter reports were of wind damage were a bit earlier, it would have at least extended the severe thunderstorm warning up into this area for a bit longer. That's how important a report can be in the warning process and so forth. And in this case here, it was very hard to see the tornado. You saw the tree come down here in the video. This tornado, as some are in our area, can be rain wrapped, meaning the rain-free base actually has heavy rain in it, kind of what we call a high precipitation supercell. This is back to Walcott, Connecticut, July 2014. You can see here there's definitely rotation and maybe a wall cloud here. Hard to see anything else. You could try to move positions to see if you can get a better look at this. On the radar, not much to really see here. Maybe something here in this area. doesn't look terribly impressive on radar. And this is in an area where kind of all three of the radars are kind of the furthest away point for all three of these radars, and very hard to, even from the radar view, kind of know where you are and what you are seeing. But clearly there's rotation and upward motion and a wall cloud there. This was actually on the ground, but from the specific video, you couldn't see it with the trees in a way. And this is where can you move your position and do so safely based on what you're seeing on the radar and just reporting again what you're exactly seeing. We have hit the break here, so we will take a short break. We'll take about a 5-minute or so break. We will come back here. I have 11:14 here. We'll say we'll come back at 11:20, and we'll continue with the second part of the presentation. Jim, are there any questions in the chat that we should maybe hit quickly in the break time before we take a short break?
Yeah, absolutely. And, while we give Rob a couple of seconds here to, get a drink of water or whatever, I just want to remind everybody that towards the end of the presentation, we'll be directing everybody to an optional quiz that'll be used to certify your attendance here and get your spotter training information. So please be sure to stick around towards the end of the presentation. We've had a couple of questions come into the Q&A box during the first half of the presentation. Thanks to everybody for their feedback about the audio. I know we were trying to address that as best as we could. So what we'll do is we'll go through a couple of these questions now. And again, if anybody has additional questions, please feel free to add them to the box, the Q&A box, and we'll get those for you. First question comes from Joel. And the question, Rob, is these rotations look counterclockwise, and I thought you indicated that tornadic rotations are clockwise. So I think if you have a moment, if you want to answer that, that'd be great.
Yeah, say that again, Jim, on the question.
Yeah, sure. Question is, these rotations look counterclockwise, and I thought you indicated tornadic rotations are clockwise.
No, I mean, you can have counterclockwise rotation, but in most of these videos, they are actually going clockwise. There is cases where you can have counterclockwise rotation, but in general, these tornadoes are occurring with clockwise rotation.
Okay, excellent. And next question is a squall line bow echo also a derecho?
Well, it depends on the strength. So derecho has a specific definition of it has to extend roughly, and there can be some exceptions. For example, if it forms in a certain area and goes off the coast before affecting more land, but generally speaking, it has to be 240 miles or longer in length, and it also has to have an extent of higher speed winds. There isn't a specific criteria on what those higher speed winds are, but it has to meet that specific that level of criteria, and they will review damage photos and other information to kind of determine whether it meets the criteria of a derecho. For example, the Wednesday, October 7th, 2020 event, it wasn't until several days later that they determined that met the criteria for a derecho. Some other cases, like for example, what happened in Iowa last summer, it was clearly a derecho just from the signature. Ours was a little bit different because if you looked at it, it certainly didn't look like what we had in Iowa, but sometimes what you can get is a lower top squall line, which can produce conditions of a derecho, and that has happened in the past. So it's really just based on kind of the how widespread, very potent winds of, say, and again, there's no set criteria, but say roughly 80 miles an hour or higher are seen across the extent of the line of storms. If you looked at the derecho from October 7th, there were 250,000 without power, and there were measured wind gusts over 80 miles per hour in a few locations, and there were direct structural damage reports in a few areas. And I think all of those things combined with the radar, combined what was seen for reports, is what led to that classification. So not all squall lines are derechos. Derecho is a fairly rare thing. The last ones here in New England were roughly, there was one in 2006, and there may have been one classified that in the 2010 time frame. So they are fairly rare in occurrence here in southern New England, more common out in the Midwest and Southeast U.S.
Okay, great. Thanks for that. Next question comes in from Barry. Is the radar always picturing the same height of the storm, or does the slice come from different altitudes depending on what activity is going on?
So repeat that one more time, make sure I have it right.
Sure. Is the radar always picturing the same height of the storm, or does the slice come from different altitudes depending on what activity is going on?
Yeah, no, so it has multiple elevation angles, and it's always slicing from, and it depends on the curvature of the earth how low it is, but it will there are at least a dozen or so elevation angles, and it's always slicing the storms at each elevation angle. And that's why it takes so long for the radar to scan. So the fastest scan for all the elevation angles is 5 minutes. You can get a scan of the first few elevation angles within 2 minutes and have that render on a radar image using what they call the sales algorithm. But it's always slicing the storm at every elevation angle when you're talking a full scan of 5 minutes. And then how low that is dependent on where it's going to be a higher altitude out in Springfield versus, say, in Foxborough because of the curvature of the earth and where the radar is located. And those elevation angles go up with height based on the curvature of the earth. And so that means your highest angle will be higher in Springfield versus, say, in Foxborough, it'll be lower because of just where the radar is and how that beam is scanning at each level in height.
Sure. We got a couple of other questions. I know we're approaching the end of the break here. I'm going to combine these, and I know it's we can't recommend specific products from specific manufacturers, but I do have a couple of questions, Rob. One is, where can I get an anemometer? And another was how to obtain NOAA weather radio. So a couple of product-based questions there.
So I can answer those questions and just say that these are not National Weather Service recommendations on products. And I'm a volunteer with the office, so I'll kind of represent this as just my opinion, not representative of the National Weather Services. They can't endorse products, but I can tell you just from my experience what products are maybe good here. One is so I'll start with the weather stations. Certainly Davis weather stations are kind of one of the most popular ones that are out there that are in use that are looked at. An up and coming one, I'll say, is the weather flow sensors. They have a number of weather stations out there that are becoming of interest, some different measurement techniques, including different ones for wind that weather flow utilizes. So there's those weather stations as well. So those are the kind of the top two. I have a Davis myself. I've been quite pleased with it over the years. So that's personal experience. And then, like I said, there are these weather flow sensors, which have kind of caught my interest as something that might be kind of an up and coming weather station that can be looked at and used. For NOAA weather radios, it's interesting. I believe even though Radio Shack has gone out of business, they're still they're still out there. They're weather radios. There's also Midland weather radios. There are a couple of others that I'm blanking on the brand names that are also available. And then certainly if you own or look to want to own different radio public safety scanners, a lot of them have built-in weather radio capabilities and sometimes including weather radio alert capabilities depending on the brand. So there's some suggestions there from a weather radio perspective. And again, these are just my own opinions and experience, nothing endorsed by the National Weather Service.
Okay, so as we start to gear towards the second half of the presentation here, Rob's going to get set up for the second slide deck. There's one more question that came in that I can answer pretty quickly. Mentions having a spotter ID that is 8 years old and have not renewed it since, and wondering if they should take the quiz. And the answer there is absolutely. We do want to refresh your training every 5 years or so. If you do have an existing spotter ID, even if it's only a few years old, definitely take some time, take the quiz towards the end, get yourself recertified, and that will reset that clock on your spotter training for the year. So with that, I'm going to turn it back to Rob for the second half of the presentation, and we'll continue to monitor the Q&A box for any additional questions that might come in for the remainder of the presentation.
Sounds good, Jim. Let me just step away for 1 minute, and then we will get started. All right, Jim, I'm back here. Are there any other questions or anything before we go into the second part of the show?
We had one brief one that came in, I guess. We can hit that one real quick. I know you'll hit it towards the end. So if somebody does not know when they last got their spotter ID number, how should they proceed towards the end of the presentation?
Yeah, so if you have your spotter ID card, or know your spotter number, the first 2 digits are the year you were trained. So 18-250 would be, the 18 would mean you were last trained in 2018. And if you took the quiz, what would happen is you'd still get, we require retraining or ask for retraining every 5 years. If you do and take the quiz and get a year 2021 number and you were trained in 2018, you'd get 5 years up through 2026. So you would get credit, so to speak, for those additional years for getting the quiz. So there's no taking the quiz and getting a new number. So you get credit no matter what. If you retrain a little early, you extend out for the years from this year. So you'll get credit for that. So, and then you could wait 5 years after the 2021 date instead of 2 years after the 2018 date. So I think regardless, getting the quiz, you will get re-upped for 5 years starting from 2021. So I would just take the quiz, but if you do have your spotter number, the first 2 digits indicate the year you were trained.
All right, and with that, Rob, you're okay to go for the second half of the presentation.
All right, sounds good. Again, good to be with everybody. We talked a bit about the different outlets for gathering information from us and when we are active. We also have a Skywarn announcement email list that Jim can put down my email information, and if folks want to be on that list, they could shoot me a note, and we can go from there and add you to the list. So for those folks that are interested in that, and that information that we post on the email list is a lot of the same info we post on social media, etc., and on our website, but it depends. Sometimes folks like to get the emails because it kind of pushes a notification to them about what's happening. So wanted to mention that. So I think that's a key thing. And I've mentioned to some folks, we are still looking at and working on some applications for phones for spotter reporting. That's still something that we're working through. I'm trying to see if we can gain some more momentum with that over the course of this spring and summer. And we'll see where that ends up here, depending on some of our technical folks and resources there. And I think there's some other interesting capabilities that we can do there also in terms of especially in the severe thunderstorm situations from a notification perspective that we need reports, etc. So wanted to mention that as well. We've named the application and program Weather Vault, and we will, as I said, I've mentioned this in the past. It's been delayed with some other work we've had going on and such, but it is something that we're still working through. So with that, we'll get into the second part of the presentation. So if it only were that easy, so spotting in New England, this is in Windsor, Connecticut. This was July 1st, 2013, and this is a tornado that went through the Windsor Locks, Windsor, Connecticut area. And you can see here's the tornado, and you can see this tobacco netting that was flung across Interstate 91. The person got so interested in that flying by. Where did the tornado go? You kind of saw it, and it kind of went away because they were looking at that debris that flew in the air. I mean, here in New England, right, very rare to see a tornado. So it's hard to kind of stay focused on, well, let me just stay focused on where that tornado is and where it may be traveling versus the debris in the air. So just, some of the challenges of spotting in New England. This was something here, this definitely might be a wall cloud. Can't tell much else here with the trees in the way, and yet we were getting reports of a tornado on the ground, and it was not on the ground in Lincoln, Rhode Island. Another problem is, and I mentioned this a little bit right at the end of part one of the presentation, we can get rain-wrapped tornadoes. Common for New England to be wrapped in rain. This is in Amsterdam, New York, not far from our part of southern New England, and you can see folks are driving right into this tornado that is pretty hard to see with all of the rain that is occurring in the area here. So this is an example of a rain-wrapped tornado, and again, something that's fairly common here in southern New England. Waterspouts, they can form in fair weather. From a cold air funnel, they can form over water and grow from water to cloud or cloud to water, but they're typically weak and generally under 60 miles per hour, commonly 30 to 40 miles per hour. Many of the waterspouts that we've seen and had reported are from supercells that form just like tornadoes over the water with rotation in the storm and winds of 65 miles per hour or higher. So we have seen a lot of the second category of waterspouts over the last 10 to 15 years. Microbursted straight line winds. So the evaporation processes can cool a parcel of air, allowing the air to become more dense, and it accelerates towards the ground and then spreads out in all directions. And that is basically what a microburst is that cold air that evaporates. It's more dense. It will hit the ground and then kind of spread out over a given area, and in that area will be the damaging winds associated with that microburst. Microbursts are generally less than 5 minutes, and effects are less than 2.5 miles wide. But when they are stronger in intensity and extend more than 2.5 miles wide, they are called macrobursts. So this was June 5th, 2010, sped up time lapse at the Bradley Airport, where they had wind gusts over 70 miles an hour. This is a fairly active severe weather weekend in southern New England. There were tornado watches on Saturday, June 5th and Sunday, June 6th, 2010. No tornadoes, but we did have quite a bit of microburst and macroburst activity on both days. This in June 5th, 2010. A lot of impacts from damaging winds from microbursts in Hartford and Talon counties of Connecticut and other parts of say, south central Massachusetts. That was on the Saturday. On the Sunday, we had a squall line of storms, and in particular, the Metro West area, Watertown through Boston area were significantly impacted. We had an amateur operator who was in his apartment complex, had part of his roof blown off of the apartment complex, with the photos sent to us and all. So, that was a very active weekend, and I can tell you that in the city of Boston, that weather event on June 6, 2010 really had them looking more and more at weather preparedness, thinking that if a line of severe thunderstorms that produced a short period of winds caused about a 2 to 3 day wind damage cleanup, what could a higher end tropical system or hurricane could do? So the city of Boston really got into weather preparedness that much more after that incident. I mentioned the microbursts in the Groton, Acton, Westford area. This is in Groton, Mass, right here, and clearly a microburst signature here. Yes, there are a couple of trees that fell in different directions. Sometimes just has to do with the rooting system. The largest amount of tree damage is pointing in the same, in one direction. And it was pointing towards, notice how it's through into these solar panels and such. Part of what made the Weather Service really think, again, this is just completely a microburst, is none of these panels were really lifted up and picked up and thrown in a chaotic direction. So this is a good example of a microburst, and this came from David Hupp, which was relayed to us from a Skywarn spotter in Groton. Very helpful information, and that's one of the things right now with technology, more spotters, etc. We can get a lot more granular in depicting these scenarios, and even able to do so without necessarily being at the scene looking at it. Look-alike clouds. So these are cloud fragments that briefly resemble funnel clouds or tornadoes and hang low at the base of parent clouds. And we'll get false reports here on these lookalikes that can result here. So this is an example, again, of a Scud Cloud, and Scud is just the name of the cloud. It's not an acronym or anything. It's just a cloud fragment. Notice it's not well connected to the base cloud. It's really just a cloud fragment. We get rain. We can see a lot of rain shafts here. If you see downward motion going to the ground here, that's just heavy rain, and you can see that in southern New England going across different highways, etc. Hail shafts, a little less common to see, but we can see them here at times. And again, just you see downward motion. So it's different from when we're seeing a funnel cloud or wall cloud with rotation. Again, this is just a cloud fragment. I know it looks like it's extending to the ground, but it's not well attached to the cloud base, and very common that we'll see a lot of these kind of cloud features in our region, and they are just cloud fragments. This is March 2016. I mean, there weren't even any thunderstorms in the area, but this is just low clouds, and this is fog in the valley. It looks like it's all connected and such to the, is this really a tornado? No, this is just low clouds and fog, giving an image that looks tornadic, but it really isn't. Another example here, this looks like a rain-free base, but again, the cloud feature here doesn't even look really attached. This is just, again, a cloud formation not associated with any type of wall cloud or funnel cloud scenario. Another example here, the ground looks wet here, but it looks like we may be actually on the leading edge of the storm here. So this does not look like it's tornadic, and again, very hard to see with the trees in the way. And we're showing these to you not to make you fearful of reporting, just to make you really strongly think about where you are in the storm, what's happening. Take a look at the radar. Is there anything going on, so that you kind of know what you're looking at in certain in these situations. And you want to use common sense and not get caught in the wrong place at the wrong time. So this is a video we've shown in the past trainings with the Raging Bull in Spain, and you definitely want to get away from the bull and not necessarily go pulling in its tail here, and causing more problems. So again, some humor around using common sense safety procedures here when seeing severe weather. So tornado safety indoors. Your shelter or place to take cover should include first aid kit, shoes, and a whistle. And you say, well, do I really need these things? Well, this is June 1st, 2011 in the Munson, Mass area, and you can see the significant damage to homes and structures. Not a bad idea to have this stuff ready. You want to go down to the lowest level, under something sturdy, cover your head, and keep in shelter until the storm is passed. The duck principle of staying safe during a tornado when you are indoors. Then tornado safety in cars. We want folks to get out of their vehicle and get into a ditch or ravine or a reinforced structure if at all possible. At a last resort, if a ditch isn't near, buckle in and lower your head below window level. I know sometimes folks have seen people put their cars underneath overpasses. I mean, if it's far enough away, that might be okay, but if it's too close to the tornado, the overpass could actually accelerate the wind speeds that go under that overpass. So that's why the suggestions are: find a reinforced structure first and foremost. If not, go to a ditch or ravine, or stay in your car, but lower your head below window level. You really don't want to be in a car this close here, as you see in the video, to a tornado. It can be quite dangerous and hard to find a safe location to be in. This is Cookeville, Tennessee, an EF4 tornado. Notice how it pile drove this 2x4 through the window here of this car. And we saw 2x4s back in the 1995 tornado that affected Great Barrington, where a 2x4 went right through the metal door of a car and peeled back the foam rubber seat cushion. That if it hadn't done that, that 2x4 would have perforated the driver of that car. So very dangerous stuff. That's why being in a car that close to a tornado is you really want to find a reinforced shelter. These are some tornado sheltering guidelines to seek the best range of options. You see the worst options: mobile homes, vehicles underneath the highway overpass. Bad options are the big rooms and gymnasiums. Better idea is an interior room, like a bathroom or a closet or basement. And obviously a tornado or storm shelter or FEMA safe room, which is more rare, but gives you the idea of the different options of where you should find another option and what you have as good and best options to stay in place until all is clear. And this, you can see, this was recommended by FEMA. For lightning safety, there were 20 fatalities in 2019, 0 fatalities in southern New England, 82 people injured in 2018, none in southern New England. Most people struck by lightning live. It is okay to touch a person that has been struck. When thunder roars, go indoors, because lightning is the #2 weather-related killer. You want to remain in cover until 30 minutes after the final clap of thunder, because the lightning can strike with a thunderstorm in the area a good 20 or so miles beyond the actual storm center. So that's a key item when dealing with lightning, that it doesn't have to be right where the storm is. It can be in areas just outside where the storm is. So very important. High wind and hail safety. So most homes are not built to withstand sustained hurricane force winds of 75 miles an hour. So you want to use common sense, know where you are in relation to the storm, and stay inside away from windows. This is from August 4th, 2015. This set a record since 1950 for largest hail ever recorded in the city of Boston, upwards of tennis ball size hail, just over 2 inches in diameter. And this was from the morning storms in Rhode Island, with the significant tree and wire damage in the state of Rhode Island, that produced more power outages than Hurricane Sandy. And this was a powerful complex of severe thunderstorms that went through on the morning of August 4th, 2015. So one of the more active days of severe weather in our region that year. So flooding safety, you want to turn around, don't drown. 6 inches of swiftly moving water can knock the adult off his or her feet. 2 feet of water can make most cars and trucks float away. 6 inches of water maybe if it's a zip car. But seriously, flooding is sometimes underrated for what it can do to people when they drive through flooded areas. So you want to turn around, don't drown when you see flooded roadways. It just takes 6 inches to knock an adult off of his or her feet if it's moving swiftly, and 2 feet of water can make most cars and trucks float away. Hurricane safety, as we watch Al Roker here in the video, any tropical system with a name in the Bahamas has the potential to affect New England. Don't focus on where the eye is going to make landfall. Be aware of where you are with respect to the track of the eye. If we're in the south and east parts of the circulation, we're going to get the damaging winds and maybe severe weather and tornado threat. If you look at Tropical Storm Isaias, we had very little rain, and that's what literally happens on that south and east side, but we get the strong and damaging winds and the potential for severe weather. On the west side of the storm, less wind, but more of a threat of heavy rainfall. You will get some wind on the west side, but less so than on the east side, and that's because on the west side, you subtract the forward speed of motion from the system in terms of highest wind speeds. On the east side, you add that forward speed of motion to the wind speeds. And we did see that it was only tropical storm strength when it was up here, but we did see that with Tropical Storm Isaias last year. We were on the high wind, severe weather side of the storm, a lot of pockets of wind damage and strong wind gusts from that system, especially in the western parts of our coverage area, Western Mass and Connecticut. You want to run from the water and hide from the wind and be prepared because it is important to be able to be self-sufficient for 3+ days. For winter safety, we just got out of winter. It was roughly average to maybe slightly above average winter, depending on where you were, maybe a little below average in southeast New England. From a winter safety perspective, you want to prepare and winterize your disaster kit in your home and car. Have a plan in place so that you can gather info about the hazards and then meet, implement, practice, and maintain your plan. Know what to do if you were caught driving outside and be aware of hypothermia and frostbite. Now you know how to be aware and to be safe. Now what to look for while spotting. So as I mentioned, we haven't told you guys what are we looking for in terms of reporting. So the spotter role, what do you report? So thousands of lightning strikes per minute. There are 1,000 house fires in southern New England from thunderstorms. Is that going to be classified severe by Weather Service definition, or even 50 inches of rain in an hour? And you know, there's massive flooding. Whole cities and towns are completely submerged and not accessible. Is that going to be classified as severe, meaning a severe thunderstorm warning being issued? The answer to both of these questions is no. But we definitely want to know about the flooding. In terms of lightning, if we have house fires due to lightning, any injuries, etc. from lightning, we do want to hear about that. But we don't want to hear that there's a lot of lightning in the storms because that can be detected by many other methods. From a reporting perspective, severe criteria reporting is winds anywhere greater than or equal to 58 miles per hour, hail greater than or equal to 1 inch in diameter, tornado or widespread damage. We definitely want to get reports of all of these. And we want folks to kind of use the TELL principle, the time of the event type, location of view, and the location of the weather event. At 6 p.m., I observed a wall cloud. I am about 5 miles south of Boston, looking to my northwest. At 11:30 a.m., I have two 12-inch diameter trees down on Wampum Drive in East Taunton. That's an example of a specific reporting. Certainly want you to be more specific than this. Ohio, looking up at the sky. You know, that's not very helpful, right? And we want folks to stick to our reporting criteria. The type of event, you know, the 3 W's of reporting, What's the type of the event? Hail, report the largest hailstone. If you want to give us a range on the hail because of different sizes, that's fine. Make sure you include the largest hailstone. The wind, report the highest gust. When did the event happen? Currently, 5 minutes ago. Where are you located? Where did it happen? We look at the videos here. The wall cloud, as you see, this is from June 1st. This is when the EF3 tornado, this was in the wall cloud stage. This is in the funnel cloud stage here. And then the tornadic stage, this was actually where it was picking up water over the Connecticut River. You can see the different variations of when to report on the different stages of a tornado. We want to hear about wall, funnel, or tornado cloud reports. Obviously, real time is the most effective, but we'll take reports anytime because it's important for verification, historical records, etc. So we like to get reports anytime, but obviously near real time is best. High winds, you'll notice here, we want healthy branches 4 inches diameter or larger down, measured wind gusts of 40 miles per hour or greater. So severe is 58, but we want folks to report in wind gusts 40 miles per hour or greater. Any kind of building damage, power lines down, healthy trees down. Again, near real time is the best, but we take reports anytime. This was an example of the high winds on August 4th, 2015 in West Warwick, Rhode Island. And again, that was a formidable severe weather event for the state of Rhode Island and portions of southeast Mass on the morning of August 4th. In the afternoon, we had another round across western and northern Massachusetts, which was more of a large hail event, but some pockets of wind damage as well. Reporting hail, pea size or larger. So basically 1/8 inch in diameter or so or larger. We used to say any size hail, and we had some well-intentioned spotters from Western Mass report sand size hail. So maybe a few grains of sand, more up to about 1/8 inch in diameter or so, pea size or larger. Prefer reports in inches, but we can use common objects such as coins, quarter size hail, $50 size hail, golf ball size hail as an example. So different types of common objects. Please don't use marble size hail because there can be different size marbles. By Weather Service definition, marble size hail is 1/2 inch in diameter. If we get that, we will generally question folks about, well, how much in fractions of an inch, or is there a better object to describe the hail that you're seeing? So again, real-time reports is best, but we'll take reports anytime. And reporting rainfall has to be through a rain gauge. It can be the fancy Davis weather stations or whatever, but it can also be the plastic Cocoa Ras rain gauges, which are very accurate. Rainfall, 2 inches or more anytime, 1 inch or more if it occurs in an hour or less. Observed river or small stream flooding, streams out of their banks. Again, taking reports in near real time, but we'll gladly take reports anytime of these conditions as well. Alternate transportation, this was from the Mother's Day floods of 2006 up in the North Shore of Massachusetts. When reporting flooding, we want folks to be specific. So cars floating, rivers rising over their banks, as you can see here in Deerfield at the Bridge of Flowers in the video on the right. A road washout means the road is gone. So not that it's flooded, it's no longer there. So that's an example here of a road washout. So being specific on the types of flooding that you're reporting is very helpful. And specifically, road washouts are where part or all of a road has been washed away. Reports of street flooding. So you can see here I had a relayed report of a friend of mine at our professional workplace. This was flooding in a parking lot. This is definitely what we want to hear about here. This was flooding up to the bumpers of the cars here. So 6 inches or more of water depth across a whole road or a travel lane. Road closed due to flooding. Jim Palmer, who's on with us today, he sent in this photo. This is not what we want reported here. However, Jim will tell you that several hours later, this parking lot turned into the left-hand side picture parking lot. Isn't that right, Jim?
Yeah, that's correct. It was only a matter of time before I had Class 1 whitewater going through the parking lot here. So this was a precursor. Obviously, knowing the area helps, being from Peabody. So I was able to give them a heads up. This is what it looks like now. However, a couple hours later, it was like I said, whitewater rapids and multiple waves going down the street.
Right. So this is if you see something like this may be something that you keep an eye on, but you don't report in, but it could become what is in the left-hand photo with the whitewater rapids, as Jim alluded to. So again, 6 inches or more of water depth across a whole road or travel lane, road closed due to flooding, etc. Reporting winter storms, so you can have ice jams along area rivers, especially in western Mass, western and northern Mass, and parts of maybe northwest Connecticut. Certainly coastal flooding at the coast, snow and ice. Reporting ice jams, we want folks to report how much of the river is blocked near any bridges or bends, any flooding upstream due to the jam, and if or when the ice jam breaks. We were very lucky this winter. We kind of had a dry spell in March and warmer enough temperatures where ice jams were not an issue this year. Reporting snowfall, we want folks to report when at least 2 inches has fallen, and if you get an inch or more in an hour, and report a final total at the end of the storm. In particular, it's great to get those reports of the first inch or 2 inches that have fallen, and then periodic reports throughout the event, and then a final total at the end. You know, some of the storms that we had this year that had the high snowfall rates over a period of several hours, very important to get those totals in those situations because they can very quickly move out of a snowfall range forecasted, and getting those spotted reports allow folks to at National Weather to upgrade their forecasts on snowfall as quickly as they can. A final total at the end of the storm is also extremely important to have kind of the final record of what that storm produced. Snow squalls are reportable. Thunder snow, of course, is reportable. And Jim Cantori loves to hear about thunder snow, but it's also important because thunder snow can be differentiated from what else may be seen on the radar, and a quick change from rain to snow or back. Talking a little bit about snow squalls, they are heavy-lived bursts of heavy snow that can be accompanied by gusty winds, reduced visibility, and quick snowfall accumulation. They're similar to blizzard conditions, but they happen for a very short period of time. Often causes chain reaction accidents that are usually very noteworthy and something we're trying to guard against. This is a time lapse of a snow squall taking over New York City. So very interesting to see this. Notice how all of a sudden your visibility goes down to practically zero. So here's another view of it. And again, visibility goes down to zero, and it happens so rapidly. So this is why it's so important to have a level of reporting on these, and there is a snow squall warning that can be issued for these short-lived bursts of heavy snow accompanied by gusty winds, though they'll be issued fairly rarely, especially in our area. A quick reduction in visibility and will cause a brief snowfall accumulation. Types of reports we're looking for is visibility less than a quarter mile. Any kind of pictures or videos that can be safely given to us via social media, email can be useful. Any accumulation of that snow. Sometimes you can get a quick couple of inches from a snow squall, and any accidents due to the snow squall. All of that information is helpful in kind of understanding the impacts of that snow squall over a given area. To measure the snow, you want to find a clear, flat, open area away from trees and buildings and take measurements around the area, avoid drifts and bare spots, and report the average value. Measure snowfall in tenths of an inch, rounding, if we get a report of 5 1/4 inches of snow, we'll round it up to 5.3 inches. Do you clear your spot? It's not necessary, but if you do, please wait 6 hours. So don't clear your area within a period of definitely keep the minimum at 6 hours between cleanings, because if you do more than that, you will be then measuring snowfall rate versus accumulation. So that's some of the information there. Reporting ice. So we had this last year, and we worked with the Weather Service to kind of fine-tune the measuring ways to measure here. So there are different methods of measuring ice accretion on surface objects, with the two most standard being elevated horizontal ice thickness and elevated mean radial ice thickness. And the official ice accumulation forecast is elevated horizontal ice thickness. Pictures are best when measuring, but you can see here, this is what radial versus flat surface ice measurements are. And essentially on the top picture here, this would just be the elevated horizontal ice thickness. It would just be a straight measurement. In this here, you would take the measurements on both sides and divide to get to your ice measurement. So that's a bit of a clarification around the ice measuring techniques there. On reporting coastal flooding, we want to hear about splashover, flooded shore roads, any kind of structural damage or beach erosion. We're always looking for coastal flood observers to give us reports along the coast, even when it's these more minor coastal flood events. It's very helpful to understand if we are getting any kind of flooding at all and the extent. So good to have that information available to us. So that's reporting on coastal flooding. With hurricanes, we want all the same reports that we have during other severe weather events: rainfall measurements, wind measurements, 40 miles per hour or greater, tree and power line damage, structural damage, stream flooding, coastal flooding, and the extent of any flooding. Any obviously street flooding that's closing down roads, coastal flooding, shore road flooding, any issues to structures because of the coastal flooding. But always remember, in hurricanes, safety is number one. We want people to be precise in their reporting. False reports, false warnings can result in no actions and fatalities or injuries. And when you become a Skywarn spotter, the report is really looked at as a lot of people are listening to us. So take a deep breath, report only what you see, not what you think or wanted to see. In terms of what you heard someone else saw, there are a lot of us, some folks are involved in public safety. I think that's definitely a bit different. There's some of us that are able to relay information from public safety resources as long as it's done correctly. We can always, and we know that it's relayed, we can always go back and look at that information and make sure that is what's happened in a given area. But in general, just report what you're seeing and directly what you're seeing. And if it meets the criteria that we've set forth here, let us know about those conditions. Going back into a little bit on flooding and do's and don'ts. So this flooding here report from Eric Carty, well, not really looks like flooding to me. I mean, there's a little bit of water in the travel lane. It looks under 6 inches. Looks like it's maybe something that could turn into that if it turns into more if it's raining hard, but really just looks like non-criteria flooding here in Hopkinton and just a little bit of standing water. Whereas on the right, this is water over the road, splashing over the roadway. We're getting debris, seaweed, etc. in the roadway. This is something we definitely want to hear about. Photo credit here from Mark in Winchester, Mass. This is just, again, some standing water. Not quite criteria here. Maybe it was a bit earlier. It looks like the rain may have lightened up there. Not something that we would report. But on the right-hand side, this is a mudslide that affected parts of a roadway in Chester, Mass. And that's definitely something that we would want to hear reported. So this should actually be reporting high winds here. So we'll definitely fix this slide. But so on reporting of wind damage, we definitely want to hear about whole trees and large branches. Definitely report that. But don't report twigs here. These are definitely smaller than 4 inches in diameter. But if these twigs are down by ice, they are a great way to report ice thickness. So it can be a way to report in on ice thickness and let us know if we are seeing that kind of damage. Reporting wind damage do's and don'ts. Report what you see, not what you think you've seen. So don't try to worry about, is it straight line wind damage? Is it microburst damage? Is it tornadic damage? Unless obviously you saw the actual tornado or saw the actual winds occur. Sometimes you may drive up and find damage from a passing storm. Just say, I have several 10-inch diameter trees down due to strong winds from the storm. That's what you see, and then let us worry about, is it straight line wind damage? Is it a more concentrated microburst path of damage, or is it tornadic damage? Reporting do's and don'ts on clouds. So this is a cloud formation here. We're going to watch this. We can see some upward motion potentially and such. Doesn't look all that connected to the cloud base right now. So it's something we'll watch. And I definitely wouldn't report anything in yet, but it's something that I would have my eyes on to see if it turns into something more significant. So this was in Ellington, Connecticut. And this was July 10th, 2013, which was a day with potential for tornadic activity, and did have a tornado on that day in Connecticut that we'll talk about a little bit later. And this is in England. This is Whitchurch, England. And you can see that, it looks like it has a funnel type shape. Looks like it's also raining. Maybe it's on the leading edge of the storm. Hard to tell. I don't see any rotation. It's something, again, I would watch, but nothing here that I would see reportable. And nope, that's not debris. That's a bird flying by. So, again, I think this is something I would just keep an eye on, but not necessarily report right away. We talked about lightning. Definitely be aware of the lightning threat. It's underrated and is the #2 weather-related killer, but don't tell us there's a lot of lightning, because we can tell that from other means. If it's caused a house fire from lightning, an injury and such due to lightning, we do like to get reports on that. We talked a lot about preparedness, the websites, the social media, the web and mobile apps, reporting, time of event, event type, location of view, location of the event, and have a plan in place. Gather info about the hazards to meet with your family to create, implement, practice, and maintain your plan on weather preparedness for a given storm situation. When you have completed the quiz, you will get an 800 number on your spotter ID card to call in reports, especially for the non-amateur operators. That's a way to report in. We also have a web-based spotter report form that can be used, especially for rainfall and snowfall. Don't use it to report a tornado on the ground, and certainly social media for pictures and videos. For amateur radio, we have a list of frequencies at wx1box.org. We are also on Echolink and IRLP. It's the new ING3 conference, and also IRLP 9123. And you can call for WX1BOX or KD1CY, because we haven't been at the office due to COVID. And those are methods that you can get us information. I mentioned a little bit about CocoRAS and the really accurate rain gauge that they have. That's the Community Collaborative Rain, Hail, and Snow Network, a grassroots volunteer network of backyard weather observers to report basically precipitation, rain, hail, and snow, regardless of the precipitation amount for their local communities. That's cocoras.org. And there's a number of folks that are also, who are Skywarn spotters, that are also CocoRAS observers. You can find spotter information via the Enhanced Hazardous Weather Outlook in our coordination messages. We are always referencing the Enhanced HWO, and you can find the Skywarn page at the bottom corner of the Weather Service page. You can see the refresher training and training quizzes that are available. We are always, again, asking folks to retrain every 5 years to keep the knowledge fresh and to keep our spotter information accurate, because we're always having about 10 to 20% with different addresses moving out of the area, et cetera. So the retraining helps. There's also some new information, roughly, I would say, on an every 5-year basis, where the retraining is helpful. And again, it keeps your information fresh with us. So that brings us to review time. So what type of weather would we expect here? So this is Provincetown, Mass, 2013. It's spanning across the horizon here. Jim, any thoughts on what this is?
I don't know. It kind of looks a little bit suspect. Like you said, it does expand horizon to horizon. It's on the leading edge of the storm, I believe. So by the process of elimination, I would call that a shelf cloud.
That's right. It's a shelf cloud. And what can we expect under the shelf, Jim?
It depends. Are we talking a kitchen shelf or a storm shelf? But if we're talking the storm shelf, I would say we're expecting our strongest winds to be underneath the shelf.
Yes, that is correct. Yeah, if it was a kitchen shelf, it would be something else, I'm sure. So what would we report here? So I'm just going to let the video play here, and there's no sound with it. So You kind of see in this video, saw that feature at the beginning, and now suddenly you see a fire. I don't know, Jim. I don't know what to say about this one myself. I think I'd say I don't know. What do you think, Jim?
I would also go with I don't know. I think it's important to note the spotter reported a lot of upward motion here as opposed to downward motion. But again, you see the fire, so you're really not sure what's going on.
Yeah, it might be smoke in the field.
Could be.
I don't know. So, not trying to trick everybody here, just getting people to think about what they would report based on what they are seeing. So that's what this is intended to do here. Night after heavy rain fell in town, you drove up the road and see this. Would you call the weather service? I definitely would, Jim. What about you?
You know, it's definitely something suspect, especially if it's in the area of a culvert or a place where we gather a lot of rainfall. So I would probably call and I'd be reporting, flooding damage to the NWS, and if applicable, I would also be notifying my local public safety as well.
Yes, absolutely. I would also notify public safety of the. If you can drive up to this, because the last thing you need is a distracted driver who doesn't see this and ends up in the washout area. So I would also call public safety if you're able to drive up to this so that they can close off the roadway. You wake up in the morning and see this on your trees. Would you call the weather service? I definitely would.
I would either be calling the NWS or reporting on my nearest Skywarn amateur radio net. And how much ice would you say has accreted, Rob?
So this, I mean, it looks like a elevated surface. It's all on one side. So this looks like a half-inch of ice here.
Yeah, I would tend to agree. It does look like a half inch.
So that's so definitely would want to hear about this. A cold winter night, and you're on the coastline, and you see this. Would you call the weather service? I definitely would. This is splash over a seawall, causing some minor flooding on the other side of the seawall. I definitely think weather service would want to hear about that. It may be in the typical area of Scituate, but it's good to document this so that you can kind of know the conditions based on what occurred here on this given day. So I would definitely report this.
Yeah, I'd be reporting that too. And just a little bit of a pro tip, Rob, because being somebody that's out there also observing coastal flooding up here on the North Shore, if you are going to take video of coastal flooding, please do not get too close to the seawall where the water's coming over, because I do see a lot of people trying to catch that picture in that video, and that splash over can approach very quickly at high altitudes.
Yeah, and you don't want it to damage your electronics with that salt water, not to mention, the safety hazard it could be to you. So good to point that out, Jim. What about this, Jim? What do you see here if you were on summer vacation in Manomet, would you call the weather service?
Well, I mean, from what I can see here, it looks like there's a Skywarn spotter standing on the beach. He's got his phone in his right hand. He's ready to make a phone call for 2 waterspouts right there over the water.
There you go, and that's exactly what you should be doing. I know it looks clear on the other side, but these are 2 waterspouts. One actually made it to shore and flipped over a guard shack stand, and it was actually classified as a brief EF0 tornado that on Manomet Beach, and that was in August of 2012. So that's definitely reportable. Anything reportable here, Jim? I don't see much of anything.
I mean, I'm a little bit concerned about a sunburn developing. Maybe it looks like some SLC, scary-looking clouds in the background, but nothing worth making a phone call to the weather service over here.
Yeah, I also happened to check the radar, and there was no precipitation, so just some interesting cloud formations here. Nothing to report. So now this is Coventry, Connecticut. I mentioned July 10th, 2013 here. What do you think we got here, Jim? I think we definitely got upward motion and rotation. We at least got a funnel cloud here, don't you think?
Yeah, I see some rotation. I see some upward motion there. I can't see what's quite going on in the background. There's some trees in the way, but I definitely would see at least a funnel cloud. Oh, wait, it's okay. I got a full picture now. Oh, yeah, I'd call a tornado on the ground.
Yeah, I think it's just about on the ground at this point. It's still a little tough to tell with the trees. It's definitely on the ground now. Look at that debris. I definitely got to call that in as a tornado on the ground there. So this was Coventry, Connecticut, July 10th, 2013. This is an EF1 tornado that had a discontinuous path from the Coventry, Connecticut area into Mansfield, Connecticut, over about a 10 or 11 mile discontinuous stretch here. So that's a tornado touchdown here in the Coventry, Connecticut area. You're driving into the city and you see this, what you call the Weather Service?
I might call both the Weather Service and the Coast Guard here. It looks like half of the community there is underwater. I'd certainly be reporting a water level depth up to the passenger side windows because I can see that. And obviously, make sure nobody's in the vehicle. If you do notice anybody in the vehicle, you might want to notify public safety as well. But that is significant street flooding in the area of Fall River.
Yeah, absolutely. And this was from the remnants of Tropical Storm Lee, which dropped about 5.5 inches of rain in about 90 minutes. And yep, Fall River has some drainage issues for sure in this area. It's definitely one of the more flood-prone areas, but that kind of rain can cause this kind of flooding, especially in an urbanized area. You're driving into the city and you see this, which you call the Weather Service, and I definitely would. This is probably the minimal criteria. These branches look fairly healthy, maybe a little bit of rot there, but we're not tree wardens per se. I would call this in as a couple of large branches greater than 4 inches in diameter down, blocking this roadway here.
Yeah, I would myself. I would also go out on a limb and report that that is wind damage.
Yeah, that would be, I think, minimum wind damage potential here. And then we'll let the audio go here if folks can hear it. And, you know,
It does look like it's coming right at us. I mean, are we supposed to go to the basement or should we actually try to vacate? Yeah, I think so too. I don't think it's that big, huh? It looks like it's gonna hit the house.
yeah. So I don't know, Jen. What do you think? Do you think you should take cover? I don't know if it's that big, right?
I'm not sure. I mean, it's tough to tell. I mean, these EF3 or larger tornadoes. If it was me, I would certainly report it, and then I'd be taking cover. And especially if it's getting closer, you don't want to be part of the problem. You want to be as safe as possible.
Right, exactly. So I would definitely report tornado on the ground. I wouldn't, and then I would take cover. And then if it's safe to do so coming out of your shelter, you could then report on the extent of damage from this tornado. And this was in Munson, Mass, part of the June 1st EF3 tornado path that affected the Springfield area. So with that brings us to the end of the training. So again, if you'd like to take the quiz to register as a spotter, go to weather.gov/Boston/Skywarn, and under resources, choose Skywarn Virtual Training Online Quiz. As I said, you will, when you've passed, you will get an email with the information and your spotter ID number. Please be patient. It could take quite a bit of time. The forecaster and Skywarn program leader, Bryce Williams, will get to it, but he has to do it amongst his shift work. And obviously, if the weather gets active, that can delay things a bit. It is a manual process for right now. So just be patient. If you don't hear anything for several weeks, a month plus or so, just be patient. If it goes much longer than that, you can always reach out to me and we'll see where things are at. But it is a manual process, so just be patient. And Bryce, I promise you, we'll get to it. He's very organized, and can definitely help and get to getting you your spotter ID and other information. I thank everybody for spending time with us today to do the class. I hope everybody enjoyed it, and then now I hope everybody takes their quiz at their leisure here in the next day or two to become a spotter, and also enjoy the rest of a beautiful Saturday. I know we may have some cloudier and cooler weather coming up, so I hope folks can enjoy a beautiful afternoon and evening here today. And I want to thank everybody for their time. Jim, are there any other questions or items you want to hit in the chat?
Yeah, we've had a few questions come in that we'll try to hit quickly. Of course, we did run a little bit longer than noon. We appreciate everybody sticking around for today. We're going to see if we can test Rob's memory here, because this would have been a little bit before my time. But what was the event in the 1980s that leveled the forest along the access road to Waterville Valley, New Hampshire?
I honestly would have to look into that. I am not familiar with that one, probably because it was part of in New Hampshire's area. But if take a note of the question and who it's from, and I can probably take a look at that and see what I can find out on that.
Okie dokie. Next question that's coming in, and I do see a couple of people asking about the quiz. If you're looking to head out, the link to the quiz is right on the current screen share, weather.gov/Boston/Skywarn. So make sure you visit that. Next question, Rob, is if you do not have an anemometer, would it be acceptable to predict wind speed of a certain range using tools such as the Beaufort scale?
So you can do that. I would only give the wind estimate though if you see actual damage. So I wouldn't call in with just a wind estimate without any damage. But if you see damage and you have an estimate, feel free to provide that with your damage report.
Okay, awesome. And I know you're going to have a lot to say about this next question, Rob. Definitely a great question here. Would reports of wind and storm damage heard over a scanner be acceptable, such as a fire department being dispatched to wires or trees down?
So it could definitely help us. It would be better to, if you get the dispatch, to also hear what the units on scene are reporting. And also tell us that that's the type of report you're giving us. I would also say if you're giving that type of report, give it to us on the amateur radio side, the WX1, through our WX1BOX social media, versus maybe giving it through NWS Boston, because we can take it, we can help validate it. Some of us are doing some of the same activities, and we can help verify it. And also, if we pass it along on our end up into the office, then if we can't fully validate it through our resources, the weather office can make a quick call to the police and fire and question when it's post-incident enough in time to help get that verification. So that's what I would say for that. We do some of that ourselves, and we've also sometimes done that and then had a spotter without going behind the road closed signs, etc. Sometimes they're able to get enough of a vantage point doing that to get pictures of damage for us to help with a situation. Sometimes we do it several hours after the fact as well, when the scene isn't as, quote, hot and they're trying to deal with closing off an area. So that's how that information can be used and be helpful. And always obey. We always have the spotters obey the public safety people in the area and not go behind those areas in those situations.
All right, next question. I'll go ahead and field this one. This is a quick one. Somebody's looking for the link on the Weather Services webpage for the Storm Spotter, I believe the reporting form. So if you go to weather.gov/box, you scroll down towards the bottom of the page, you'll see a whole set of icons. There's 3 rows worth of icons. If you look in the 3rd row, the one on the far left says Submit Storm Report, and that's where you'd be able to go online and submit your storm report through the website. And last question I see, Rob, are the training slides online at the, I believe, the Skywarn page that's listed here? Do you know if those slides are online?
So the specific slides, I don't think however, we have recorded, I believe, Jim, you said you've recorded this session and we will make it available. The video training will be available and uploaded at different locations, so you can rewatch the video or rewatch segments of the video. But the actual, just the slides themselves are not just available. They're typically part of videos that with us narrating the slides, etc.
All right, and I think that'll just about do it for today. I know we've gone a little bit over the time. Appreciate everybody joining us today. I hope everybody gets a chance to enjoy the wonderful weather that we have going on today. Temperatures should be in the low 70s. Just a beautiful spring day today. Thanks everybody for joining us. Rob, any final words?
No, I again thank everybody for their time and support of the National Weather Service Skywarn program, and appreciate everybody jumping in and being here today despite the great weather. And hope everybody enjoys the rest of their weekend. And I think Jim provided my email contact info for anybody that wants to join our Skywarn announcement email list or have any other questions. And we could take them offline. So with that, everybody have a great day and a great weekend, and maybe we'll catch some of you at with some of your reports during severe weather that meets the reportable criteria conditions. Thanks to all for their time today.
Thanks everybody. Have a great Saturday.